Okay, so we know what to do if our quadratic is in vertex form. We can read the vertex from the equation, we can find our intercepts. But what do we do if it's not in vertex form? What if we have ax squared plus bx plus c? This is pretty common, and we cannot look at this and know what the vertex is going to be. So what do we do with this? Well, it turns out there are three different ways to find a vertex. One is to complete the square on this function in order to get it into vertex form. We've seen completing the square a couple of times. This one is very similar to the other ways that we've seen it. The other thing that we can do is we can use h is equal to negative b over 2a, where we use this b and this a. That's the h of our vertex hk. You can look in your book, I believe it's page 291, and it shows you how they get this negative b over 2a, and it comes from completing the square with a, b, and c. So what happens is you get this negative b over 2a thing that lines up with the h when you complete the square, and that happens every time. So you can go ahead and take the shortcut of using the a and the b and getting h. Now they also have a formula for k. I've never memorized it myself, and you don't need to, because all you have to do is plug h back in to find k. So negative b over 2a is pretty easy to remember. Even people that haven't used it in a while can usually remember it, and then you just plug it back in. The other way to find the vertex is to use your graphing calculator. And remember, we just said that the vertex is the highest or lowest point on the graph, which means it's the maximum or the minimum. All three of these are, I would consider, equivalent. There's not one that's better than another, but sometimes it's better to use one of them in a certain situation than the other. So we'll talk about that as well. Alright, so let's look at an example. Let's say we have f of x is equal to x squared plus 6x plus 5. So this is not in vertex form. We cannot just look at this and know what the vertex is going to be. So we've got to use one of those three methods. The graphing calculator one we're going to do in class together. So let's look at completing the square and using negative b over 2a. So let's use method 1 first. Let's complete the square in order to get this in the right form. Okay, so we know that we want to focus on the x squared and the 6x, just like we did when we completed the square on the equation. But this isn't an equation, this is a function. So we can't move this 5 somewhere else. The 5 has got to stay with us. We've got to work on one side, basically, of the equation. Okay, except it's a function. So what we're going to do is we're just going to move this 5 off to the side a little bit. It's still with us. We're just going to make a little bit of space. Alright, now, for completing the square right here, we want to get this into the form of something squared. Remember what we're trying to get to here. We're trying to get to something that looks like this. So we need to get our x's into the form of something squared. So to get this in the form of something squared, same as we saw before, you take the middle number and you're going to divide by 2 and square it. So we divide this by 2, we get 3, squared we get 9. So I need to add a 9 right here in order to get this in the right form. But now we can't just add 9 to the middle of a function. That changes what the function is. But what we did before was we added 9 to the other side of the equation to balance it out. But we don't have an equation this time. We just have the function. So what can I do here? I need to add a 9, but I also need to balance it out. Okay, so if I'm going to add a 9 to the middle of a function, I need to balance that out by subtracting by 9 on the function. Okay, so this is all within the function. If I add 9 and I subtract 9, then I haven't changed the function at all. If we simplified this, we'd be right back to where we started right here. So I want to add 9 here, so in order to balance that out, I'm going to subtract 9 here. And that's the key difference here between what we saw before and completing the square now. Okay, we're going to add 9 here, we're going to subtract 9 here. Alright, now the rest of this works the same. I want to group these x's together, so I'm going to factor. Factors of 9 that add up to 6 would be 3 and 3. So I've got x plus 3 squared, and then this is going to be minus 4. Okay, so we regrouped this. We got x plus 3 squared minus 4, and now we can read that our vertex is going to be opposite sign, same sign. So negative 3, negative 4. And we could go on to do our x-intercepts, our y-intercepts, and our graph from there. Okay, so that's finding the vertex, putting it into the right form using completing the square. Now the second method, remember we're going to use negative b over 2a. Alright, so when we look at this, a is equal to 1, that's our coefficient right here, and we've got b is equal to 6. B is equal to 6. Okay, so plugging those in, we're going to have negative 6 over 2 times 1. I'm going to write that differently. 2 times 1. Okay, so we've got negative 6 over 2 times 1. 6 over 2 is 3, so we're going to have negative 3 overall. If you want to put this in your calculator, I rewrote this because it's really important that you have parentheses around the entire denominator in your calculator. Just get into that habit now. It'll make your life easier. So put parentheses around the whole denominator if you're going to put this in your calculator. All right, so we get that h is negative 3, the h of our hk. And in order to find k, that's our y value. So anytime you want a y value, you plug in your x value. So we're going to take h and we're going to plug it back into our original equation. And we're going to get that k is equal to negative 3 squared plus 6 times negative 3 plus 5. We're going to be really careful with signs and order of operations here. This is a negative 3. All right, so we're going to get 9 minus 18 plus 5. So 9 minus 18 would be negative 9, plus 5 would give us negative 4. So h is negative 3, and k is negative 4. Okay, so negative 3, negative 4 here, negative 3, negative 4 here. Okay, so I came back and cleaned this up a little bit to make some space and added a graph. added a graph so that we can go ahead and graph this. So we've got our vertex at negative 3, negative 4. So that's right here. And we should always be able to find our y-intercept. So remember, to find the y-intercept, you put in x equals 0. So it really doesn't matter where you put it in. If you put it into the original, that's probably the easiest thing, because look what happens. 0 squared plus 6 times 0 plus 5. These first two terms will be 0, and you're just left with 5. So 0, 0, 5, that makes that a little bit easier. So we've got a y-intercept of 5. 1, 2, 3, 4, 5 right here. Okay, so looking at this, we've got a vertex here, y-intercept there. Our graph is going to look something like this. Are we going to have x-intercepts? Yes, we definitely have to cross the x-axis somewhere. So let's go ahead and figure out what those are. Okay, so for x-intercepts, we want to set y equal to 0 or set the function equal to 0. And we've got two different forms of the function. We can either set this equal to 0, or we can set this equal to 0. Okay, now if we set the first one equal to 0, that's fine. You're going to be going through all of your different quadratic ones. The second one is sometimes easier to solve because you can always use the square root method. So why don't we go ahead and go through both of them. So let's say that we went ahead and did the work to complete the square and we've got this. Let's set that equal to 0. So we're going to have x plus 3 squared minus 4 is equal to 0. And remember from that last example, if we can get to something squared is equal to a number, we can take the square root. So let's get this number on the other side. X plus 3 squared equals 4. We've got something squared is equal to a number. So let's take the square root on both sides. Don't forget your plus or minus. Get that a little bit closer. Okay, so on the left-hand side, the square and the square root cancel. And on the right-hand side, we get plus or minus 2. Let's get x by itself. And we are going to get negative 3 plus 2 is negative 1, and negative 3 minus 2 is negative 5. So we get x-intercepts at negative 1, 2, 3, 4, and negative 5, like that. And that looks good. Everything's in alignment. Okay, now before we draw that in, let's go back. Let's pretend that we didn't have that version, we had the first version. So coming up here and doing the original one, if we set that equal to 0, okay, remember running through all of our different quadratic options. First we look for a common factor, no. We look for easy binomial factors, so factors of 5, that would add up to 6. Yes, we can factor that. If we use 5 and 1, 5 and 1 multiply to be 5 and they add to be 6, so those are our factors. So we get x plus 5 times x plus 1 is equal to 0. That's the zero product rule. So we can break this up as x plus 5 equals 0 and x plus 1 equals 0. And we get -5 and -1. So there are lots of different ways that you can tackle these problems, and as you can see, we got the same answer either way. So go with the method that seems most reliable to you and the easiest way to tackle that particular problem. So we've got our vertex, we've got all of our intercepts. We can go ahead and draw this in now. So we come up like that, and we come up like that, and we've got our parabola.